In this video, we'll be solving kinematics practice problems. So let's start. A car starts from rest and accelerates uniformly at 2 meters per second squared for 6 seconds. It then travels at a constant velocity for 10 seconds and then finally decelerates uniformly at 3 meters per second squared until it comes to rest. So let's find the acceleration for this scenario. So in order to find the acceleration, we can identify that v initial is equal to 0 because we start from rest. And we can also identify that the acceleration is equal to 2, which we have here. And we can also identify that the time interval is going to be 6 seconds, which we have from here for 6 seconds for segment A. This is when the car is accelerating. Now, we can find the final velocity using the formula v is equal to v initial plus acceleration times time. Actually, move this up here. And plugging in our values, we have 0 for v initial, we have 2.0, and we have 6.0, and that's going to be 12 meters per second. Now, we're going to find the displacement. So in order to find the displacement, we can use x, which is displacement, is equal to v initial times time plus 1/2 times the acceleration times time squared. Now plugging in our values, we have our initial value for v is 0 plus 1/2 2.0 times 6.0 squared. That's going to be 36 meters of displacement. Now after this, now we have that so this was acceleration. This was accelerates. So now after this, we have constant velocity traveling for 10 seconds. So for constant velocity, this is going to be for segment B. Constant velocity. And we have that v is equal to 12 meters per second, and we have that the time interval is 10 seconds that this occurs for. So we can use the formula that x is equal to the velocity times time, and then plugging in our values, we have 12 times 10.0, and that's going to give us 120 meters. Now for segment C, we have that it finally decelerates uniformly at 3 meters per second squared until it comes to rest. So this means we can write that the initial velocity is going to be equal to 12, and we have v is equal to 0, and then the acceleration is equal to negative 3.0 because that's because we're decelerating, so we're going backwards because acceleration is a vector which incorporates the direction, so that is the reason why. And we have the equation. We are not given time, so we can use the kinematic equation cake without time, and that's going to be v squared is equal to v initial squared plus 2 times the acceleration times delta x. Now if we now this is 0, and we have our initial, that was 12 squared plus 2 times negative 3.0 delta x, and now delta x is going to equal to 24 meters. So now for our final answer, x total, that's going to be 36 meters from segment A. From segment B, we have 120. And then from segment C, we have 24. So that's going to give us a grand total of 880 meters of displacement. Now, let's move on to our next problem. A ball is thrown straight upward at 18 meters per second squared from a cliff 45 meters above the ground. So this is going to be free fall, and we also have to account for the signage. So how long until it hits the ground, and what is its velocity just before impact? Okay, so we can define our coordinate systems to be this: positive being up, positive y being up, and positive x being to the right. Now, we can write our known values, which is v initial is going to equal to positive 18, y initial is going to equal to 45, y is going to equal to 0, a is going to equal to negative 9.8. Now, let's solve a. How long until it hits the ground? So we can use the equation y is equal to y initial plus v initial t plus 1/2 a t squared. And using this, we can sum our values. 0 is equal to 45 plus 18t minus 4.9 t squared. Now, after this, we can rearrange this, and we can see that this is a quadratic formula, right? So we have 4.9 t squared minus 18t minus 45 is equal to 0. And because it's a quadratic, we can use the quadratic formula, which is x is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. Now, instead we use t is equal to 18, because t is our variable, which is similar to x here. So that's going to be plus 18 squared. And the reason why we have no negative, because time can't be negative, so you discard that. So we have 18 squared plus 4 times 4.9 times 45 divided by 2 over 4.9. And that's going to give us, if you type that into your calculator, that you're going to get t is equal to 5.6 seconds. So now let's solve part B. What is its velocity just before impact? So v is going to equal to v initial plus at. So right before impact, we can plug in our values, and we have v is equal to 18 plus 18 minus 9.8 times 5.6, and that's going to give you negative 36.9 meters per second. Okay. A ball rolls off a table 1.2 meters high with a horizontal speed of 3.5 meters per second. Find the horizontal distance traveled. Okay, so remember that x and y are separate. And this is a projectile horizontally launched. So we want to find the vertical. So that is going to be us finding time. So we know that v initial y is going to equal to 0, y initial is going to equal to 1.20, y is going to equal to 0, a is going to equal to negative 9.8, right? So now we can plug this in. We have 0 is equal to 1.20 minus 4.9 t squared. And then we have t is equal to 0.49 seconds, solving for t. Now, in order to find our, let's move this over a little bit, to find our horizontal displacement, which is what the question is asking us for, we can use x is equal to v initial xt, which is equal to 3.5 times, that was 3.5 times 0.49, which we just found. That's going to be 1.72 meters. A projectile is launched at 25 meters per second at 40 degrees. Find the maximum height reached above the launch point. Okay, so this is a projectile at an angle. So if it's launched at, okay, so you can imagine this guy is here through something, and we want to find the max height. We want to find that h. So your v initial is going to be 25 meters per second, and this angle, that's going to be 40 degrees. Okay, now to find our vertical component, VOY, you have 25 sine of 40 degrees. And if you're wondering where that came from V initial times sine of the angle, and that was just 40. And this is going to equal to 16.1 meters per second. and then we want the maximum height. And we know the maximum height, that Vy is going to equal to 0, because this is going to be the transition point between positive and negative velocity. So you have positive velocity here, and you have negative velocity here. And then in order to go from positive to negative, you know it has to cross the x-axis at least once, which is this one point. So it goes right here. Thus, Vy is equal to 0. Now, we can sub that into this equation. Vy squared is equal to V initial y squared plus 2 times the acceleration times delta y. And that's going to be equal to 0 times 16.1 squared minus 19.6 delta y. Now, delta y is going to equal to 13.2 meters. So that's going to be your height. Okay, now using the same projectile as above, find the horizontal range. So in order to find the horizontal range, well, okay, we're going to need to find the time of flight. And we know that y returns to 0 because it goes from y equals 0, then it rises up a bit, max, and then it goes back to y equals 0. So we go up, then it go up here, we go from down to up to down. So we know our equation for time is going to be t is equal to 2 times v initial y divided by g. Now if we plug in our values, we have 2 times 16.1 divided by 9.8. That's going to be 3.29 seconds. Now after this, we can find our horizontal velocity, Vox. That's going to equal to 25 times cosine of 40 degrees. That's going to be equal to 19.2. And again, this comes from V initial times cosine of the angle. And that is going to, now we can find our range. Our range, this is going to be x is equal to V initial x times t. And that is going to be 19.2 times 3.29. Now that's going to be equal to 63.2 meters. Okay. A car uniformly slows from 30 meters per second to rest over 120 meters. So Vf is going to equal to 0. And we want to find the acceleration. And what are we missing? We're missing time. What is time? So we have our V initial as 30. And we have our delta x is this. So we don't have time. So we have to use the equation with no time. So that's going to be V squared is equal to V initial squared plus 2 times acceleration times delta x. It's going to be equal to 0 times 0 is equal to 900 plus 240 times your acceleration. Because we can show that here. 2 times our acceleration. 2 times 120 times a. 0 is equal to 900 plus 240a. So our acceleration, if we subtract 900 and divide that by 240, that's going to be equal to negative 303.75 meters per second squared. 2 cars start from rest. Cart A accelerates at 2 and cart B at 3. How long until car B is 50 meters ahead? So this is going to be a relative motion question. It's kind of tricky, but it's okay. So we can write the displacement equation. So for car A, we have xa is equal to 1/2 of 2.0 t squared, and that's going to equal to t squared. Now for xb, we're going to have 1/2 times 3.0 times t squared is equal to 1.5 t squared. Now we have to find the difference of xb minus xa, because we want to find when car B, or highlight this, when car B is ahead, right? So that means that you have to find the difference of A from B. So that's going to be 0.5 t squared, which was 1.5 t squared minus t squared. Now we can set that equal to 0. So 0.5 t squared is equal to 50. And that's because this is the difference, right? So then if you just, both sides, we have that t is going to be equal, and then you also divide by 0.5. You have that t is just equal to a nice 10 seconds. Okay. A ball is thrown upward at 20 meters per second. What is its speed at 12 meters above launch? So we have to use we are not given time. We have v initial. So what does this mean? We can use v squared is equal to v initial squared plus 2 times the acceleration times delta y. V squared is going to equal to 400 minus 235.2. The velocity is going to equal to 13.1 meters per second. Velocity increases linearly from 0 to 20 meters per second in 5 seconds and then stays constant for 10 seconds. Okay. So for 5 seconds, so let's break this up into 3 intervals. We have 5, 10, and we have 15. So we know that it increases linearly in 5 seconds, and then it stays constant for 10 seconds. So we want to find the total displacement, and we know displacement is going to be equal to area under the VT graph. So that is going to be a triangle. So the area is going to equal to 1/2 times base height. That's going to equal to 1/2 5 times 20, and that's going to equal to 50. Now for the rectangle, we have that base times height, and that's going to be equal to 10 times 20, which is equal to 200. Now our sum of this, 200 plus 50 is 250 for the total displacement. A projectile is launched from the ground and lands 80 meters away. It has a maximum height of 20 meters. Okay, we want to find the launch angle and the speed. So we know that the vertical motion will give us v initial y, right? So then we can write that 0 is equal to v initial y squared minus 2g times 20. So then from here, simplifying, we have v initial y is going to equal to 19.8. If you just do plus 2g 20 plus 2g 20, that would have canceled out. Then you have this 2g 20 is equal to v initial y squared, and then you just take the root of both of those, and that's where you get 19.8. Now, in order to find the time of flight, what you can do is you have t is equal to 2 times v initial y. Divide that by 2. And we have v initial over there. We have 2 times 19.8 divided by 9.8. That is going to give us 14.04 seconds. Now, in order to find the horizontal velocity, we have Vox is equal to 80 over 44.04. And from that, we have 19.8. And now, in order to find the angle and speed, the theta is going to be equal to tan negative 1 of 19.8 divided by 19.8. And that's going to be equal to 45 degrees. And V initial is going to be equal to 19.8 squared plus 19.8 squared. And that's going to be equal to 28 meters per second. And again, theta is going to equal to tan negative 1 y over x. And V initial is going to equal to the root of, and 19.8 was V initial x, V initial y squared. And that is it.